Hello and welcome back, sports fans. We are at the end of our Law of Signs unit and solving triangles. And these are oblique triangles, any non-right triangle. And today we're going to talk about the ambiguous case. And ambiguous means unclear, and that can be something, you could have two possibilities for our triangles. But what I want to do is do a recap of how to solve any non-right triangle. And all you need to know is it a side angle side, a side side side, or that kind of thing. And we're going to give you a specific set of steps to do each one. So let's start out. These are ones we have done before, and hopefully you can find this page in your notes. It's called the ambiguous case solving triangles. The first type I'm going to talk about have three sides, side, side, side. So in other words, they give you the lengths of the three sides of a triangle. So here's your procedure. Your first step is going to be to use the law of cosines to find an angle. So if you're given side, 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 you got to use the law of cosines to find an angle. Once you find the angle, then you can use the law of sines to find the other missing angle. And then third, you're going to take 180 minus the sum of those two angles to find the third angle. Remember, when you're solving a triangle, you're finding any missing sides or angles. The second is called the SAS, side angle side. So in other words, they give you two sides and an included angle measure. So if you're given this, what you can do for here, you got to use law of cosines first again to find the missing side. And so in this case, you'd find little a over here. And second, you're going to use the law of sines to find your missing angle. I like the law of sines. It's a proportion. There's no square roots. And then third, take 180 minus the sum of the two angles to get the third angle. Once you have two angles, the third angle is very easy to find. So that's side, 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 side angle, side. Both of those start with the law of cosines. Then if you have any two angles and a side, so it's either angle side, angle side, or angle side angle. So in this case, let's say they gave me 52, 41, and they gave me this side over here. So it's two angles and a non-included side. Or you could have the side in between here. By the way, make sure your notes have a little a over here and a little b over here. I think I made a mistake with that. This one's pretty easy because first thing, I'd find the third angle by subtracting the sum of the 52 and the 41, these two angles, from 180. And then I just use the law of sines to find the missing side. Okay, missing sides. You'd have two law of sines and you'd solve it. Now what happens if it doesn't fall into any of those categories? You may remember from your geometry, you might get two sides and an angle opposite one side. Angle side side, as some would call it. I know you're expecting a joke one right here. All I can say is when you see angle side side, it is a pain in the angle side side. So this is what it would look like. They give you an angle and the angle is not included in these two sides. What makes this strange is your B over here could be an acute angle or an obtuse angle. This is what's known as the ambiguous case. So if you've got an angle side side, it's an ambiguous case because this BC could be over here or it could be this way, so that it's an obtuse angle. So the first thing you do is check to see if angle A is acute or obtuse. If it's obtuse, it's gravy. All right? So if angle A is acute, so then after I find out if angle A is acute or obtuse, you compare the lengths of the sides, little a, little b. So in other words, the length of these two sides, that one's opposite of the angle. Case 1, if angle A is acute, you check A less than B sine A. You compare A and B sine A. If angle A is acute, compare A and B sine A and see which is bigger. So if A is less than B sine A, that's not possible. There's no solution. If A is greater than or equal to B, or A equals B sine A, it's one solution. If A is greater than B sine A and A is less than B, there's two solutions. So here's the possibilities for the angle side side. Your first step is to check to see if angle A is acute or obtuse. If it is acute, then you need to compare A and B, and you need to also compare A and B sine A. If A is less than B sine A, no solution. If A is greater than or equal to B, or A equals B sine A, there's only one solution. If A is greater than B sine A and A is less than B, there's two solutions. Yes, it's complicated, but I'll show you how this works. Just take it a little bit at a time. Now if A is obtuse, you just have to check and compare the two sides. If A is less than or equal to B, there's no solution. If A is greater than B, there's only one solution, because you can only have one obtuse or right angle in a triangle. Note, you only have to compare little a with B sine A if A is less than B up here. Let's do our first example. Find the number of solutions for the given data. Do not solve. So I like to go ahead and draw the triangle, and I have again angle side side. So what I'm going to do is I'm going to say angle A is acute. Well, that's a shame, because that means we have to look and see little a and little b. Little a is the 5, little b is the 7, and A is less than B. So that means we need to go ahead and compare A with B sine A. So if we compare those two, just plug it in there. 5 is greater than 4.68. If we look at our notes, if A is greater than B sine A, there are two solutions. So we're going to stop there. If you think back to geometry, this ambiguous case should make a little bit of sense, because if you have angle A here is 42, and this side is shorter than this side, that means angle B has to be bigger than A. But the question is how much bigger? It could be just a little bigger, it could be a lot bigger. So that's why we have this ambiguous case. Number 2, so here again we have angle side side. So angle A is acute, little a is less than little b. So then we're going to go ahead and compare little a with B sine A. If we do that, we get 8 and 9 sine 73, and we get 8 is less than 8.6. If you look back at your notes, if A is less than B sine A, there is no solution. Alrighty, so there's ambiguous case in its glory. So let's take a look at this one. Angle A is obtuse. Right away that should clue you that there's either one solution or no solution, because other angles cannot be obtuse. And if I look at this one, A is greater than B. That has to be that way, because this opposite side, the obtuse angle, has got to be the longer than this guy. If not, there's no solution. So this is one solution. On this guy, they give you angle C, little a, and little c. So if we look at this, I'm going to go ahead and change angle C to angle A so it fits with our formulas. And I'm going to change C equals 11 to A equals 11, which means this guy's got to change, and I'm going to make him B equals 10. I did that just so that it would fit our formulas, but you don't have to. You can do opposite angle and so on. If I look, angle A is acute. Little a is greater than little b. What does that mean? That B has to be an acute angle. So there's only one solution, and you're done with that one. Okay, let's see if we can solve each triangle, and if there's two solutions, then we're going to give both of them. So let's look at this first guy. This guy, we've got two angles, so we know it's not an angle side side. Thank good Lord. And we can solve this pretty quickly. So angle A is 43, angle B is 97. The first step is going to be to find this missing angle. Then we'll find little b and little c using the law of sines. So I'm going to take C equals 180 minus 43 plus 97. It's going to give me a grand total of 40. Now then I can use my law of sines to find little b and little c. I will take 7 over the sine of 43. That's little a over big A, sine of big A, equals little b over sine of 97. I cross multiply and divide by that third number. So 7 times the sine of 97 divided by sine of 43, going to give me about 10.2. Now let's find little c. So I'd have 7 over sine of 43 equals c over sine of 40. Cross multiply, divide by the third, and I end up with 6.6. I always check my answers and make sure they make logical sense. Is the longest side opposite the largest angle? In this case, I got 10.2 for little b. It is largest, so everything makes sense. C, I had 6.6. 40 is just a little bit smaller than 43, so all my answers make logical sense. Let's look at this guy. We've got little a, little b, and big A. This is an angle side side, so we're going to have to go ahead and do angle A is acute. A is less than B, which means B could be obtuse. So then I'm going to compare little a with b sine a. If I do that, I get 11 is greater than 13 sine 41, so I have two solutions. Now, when you have two solutions, you're going to do it where angle B is an acute angle and angle B is an obtuse angle. Those are going to be your two solutions. So if I draw this first, I put 11 over here, 13 over here, and I'm going to put B sub 1 because this is my first possible triangle. So little a is 41 degrees. Angle A is 41 degrees. First step on this is to solve this triangle. I'm going to use the law of sines. So I'm going to get little c1 and I'm going to get b1 and angle C. So I'm going to take 11 over the sine of 41 and set that equal to 13 over the sine of b1. When I solve that down, I'll take sine inverse and I will get 50.8 degrees. So there's b1. That means angle C1 would have to be 88.2. I take 180, subtract the sum of those two. Then I need to find little c1, so I'll take c1 over sine of 88.2 equals 11 over sine of 41. When I solve that down, I get c1 equals 16.76. So this is my first solution if B is an acute angle. Second solution is if we swing that 11 around this way and our B2 is inside here. Now if you notice, this is 11. If we swing it over this way to get our second possible triangle, which would be this triangle A, B2, and C, these are equal, aren't they? That means if this is 50.8, this guy over here is 50.8. So to get the second possibility for B, I would subtract it from 180. So I'm going to take 180 minus 50.8. And this would be my second possibility for C and my second possibility for the length of little c. So if we do that, B2, 129.2. So this is our second possibility. I'll find C2 by subtracting 180 and 41 plus 129.2. So I get my second possibility for C to be 9.8. C sub 2 over sine of 9.8 equals 11 over sine of 41. Cross multiply, divide by the third. So our possibility for C2 is 2.85. Alrighty, so the second triangle is a little bit easier to find. Okay, hope that's clear as mud, and I will see you tomorrow.